solving logarithmic equations or exponential equations using logarithms. This is the key part to logarithms, all right? If you don't know how to solve equations with logarithms, then you're not going to pass your exam, okay? Or at least you're not going to pass the question on logarithms. So 4 to the x is equal to 15. I've done 3 ways here to solve it. There are many other ways. There's a million ways to solve equations like these, okay? It depends on your preference. So we can put both sides, we can take logarithms of both sides, okay? So logarithm of 4 to the x is equal to logarithm 15, all right? It's just like solving equations normally, right? You do something to one side, you have to do it to the other, all right? So if it was 4x is equal to 15 plus, say, y, it would not be logarithm 4 to the x equal to logarithm 15 plus logarithm y. No, logarithm of the whole side. So logarithm 15 plus y in brackets. Because then that will be, if you use the multiplication law, logarithm of, actually no, you can't do the multiplication law with this one. Okay? If it was 15 times y, then yes, you could do that. So, then I move the x down here using the power law. Okay, so x logarithm of 4 is equal to logarithm of 15. And I just divide by logarithm 4 to give me x. You put it onto your calculator, it's 1.953 in 3 decimal places. Another way you could do it is you can pick, by the way, if you're taking logarithms of both sides, it doesn't matter what base you pick, alright? Sometimes one base is more beneficial or easier than the other. Say if you used logarithm base 2, alright? We move the x down here, same as I did there. Logarithm base 2 of 4, you should know that. What pi have to give 2 to get to 4? That's just 2. So then it just becomes 2x equal to logarithm 2 of 15. X is equal to logarithm base 2 of 15 over 2, and that gives you that. It's more useful if all the inputs with a logarithm function, alright, are multiples of 2. Okay? So say if that was 16. Then you would get 2x equal to, well, logarithm base 2 of 16 is just 4. Then you would just get 2x is equal to 4. And then you get x is equal to 2. Okay? Now, the easiest and quickest way to do it, the most common way, alright, just convert this exponential function into a logarithmic function. So 4 to the power of x gives you 15. What power you have to give 4 to get to 15? Well, that's x. So you just put it in logarithm form, and you get x equal to 1.953. But again, if you don't have a calculator that can use different bases, alright, like base 4, and only uses base 10, you're going to have to change the base. So logarithm base 4 of 15, you have to change it to logarithm base 10, alright, of 15 over logarithm base 10 of 4. But then you just end up with this from the previous way to solve it. Okay? Why don't you try? Solve giving your answers as exact fractions, the simultaneous equations a to the power of y is equal to 4 to the power of 2x plus 3, and logarithm base 2 of y is equal to logarithm base 2 of x plus 4. Yeah, the 4 is not part of the logarithm function. Okay? Have a go. Alright, so for the first one, I first separated the powers, alright, because you're going to have to separate them anyway if you take logarithms of both sides. Alright, by the way, it doesn't matter which way you solve this equation, alright, because there's, as I said, there's a million ways to solve it. Alright, I just did it like this. So after I separated the powers of 4 cubed is 64, alright, and then I took logarithms of both sides, and I put the y in the y power down here using the power rule. Alright, and then using the multiplication rule, I separated these two numbers. Okay, then I realized I could have used base 8. Alright, this is an example where choosing a specific base is very helpful. Alright, because that means that logarithm base 8 of 8 just becomes 1, so y times 1 is y, and logarithm base 8 of 4 is 2/3, so 2x times 2/3 is 4x over 3. And logarithm base 8 of 64 Well, 8 squared is 64, so that's just 2, 8 to the power of 2. Alright, you end up with y is equal to 4x over 3 plus 2. You could have used base 2, in which case you will get 3y is equal to 4x plus 6. Alright, basically the same thing as this, just multiplied by 3. Right? Now I'm going to show you how to solve this one, at least for y, alright, because we don't have actual values for x and y yet, because it's simultaneous equations. Alright, now I'm going to show you 3 methods for solving this, because I think those 3 methods are useful ways for solving logarithms in general, and I want to show them to you. Alright, so first I want to change that 4 into a logarithm in base 2, alright? Because then it makes things easier for me. So, logarithm base 2 of 16 is the same as 4, right? I spotted that, okay? Because 2 to the power of 4 gives you 16, okay? If you didn't spot that, you could have done this, alright? Plus 4 multiplied by logarithm base 2 of 2, alright? Because logarithm of any base, in any base of that same number is just 1. So 4 times 1 is still 4, doesn't change anything. But now you can move that 4 there. So now it's logarithm base 2 of 2 to the power of 4, which is just 16. Alright, so you get to there. And then using the multiplication rule, alright, bring these two functions together into 1 logarithm base 2 of 16 multiplied by x. So right now I can just get rid of the logarithms and make it y is equal to 16x. Alright? Alright, another way you could have done it is you could have looked at the base, alright, that's 2. So put everything on that side, alright, so that's 2 to the power of everything on that side, and on this side, 2 to the power of everything on that side. So then I would, first of all, I would separate the powers using the rule of indices. Alright, so 2 logarithm 2x times by 2 to the power of 4. Alright, now, if you have a number to the power of a logarithm in its base, alright, logarithm 2 to the power of logarithm 2, then they basically cancel each other out, because it's like inverse functions. Alright, so then you end up with just y, and you end up with just x. Alright, and 2 to the power of 4 is 16, so 16 multiplied by x, y is equal to 16x, right? This method can prove very useful in certain situations, right? So, any number to the power of a logarithm in its base, alright, of any other number, alright, cancels each other out, so it's just n. Now, a simpler way, or you could argue that the ways I showed you before are just overcomplicated and unnecessary, but they do prove useful in other situations, alright, where things are not as simple as this. So you just move all the logarithm functions to one side, alright, using the division rule, you can combine them so it's y over x, right, because it's a logarithm function minus another logarithm function, right, and then you just convert the logarithm into an exponential function. So what power you have to give 2 to get to y over x is 4. So 2 to the power of 4 gives you y over x. Alright? And then you just rearrange and simplify to the power of 4 is 16. Alright? Y divided by x is equal to 16. So y is equal to 16x. Alright, I'm not going to show you how to solve them simultaneously, because simultaneous equations has nothing to do with logarithms. Alright, so in case you're wondering, the answers are x is 3 over 22 and y is 24 over 11. Next question. Alright, I want you to solve for x. Go. Alright, the first problem, different bases. It's not going to work if you don't change the bases. You have to have the same base throughout. Alright, I'm going to change it to base 3. You could change it to base x. It doesn't really matter, but my preference is for the base to be a numerical value, not a variable. So I change logarithm a base x of 3 into base 3. So then that gives me 1 over logarithm base 3 of x. This is one of the occasions where I told you, because 3 is the base And it's also what you're doing the logarithm of. So that becomes 1, so it's 1 over 3 base 3 of x. Alright? A logarithm base 3 of x. And also, this is one of the instances where you need to know how to change the base of a logarithmic function. Okay? If you didn't know how to change the base, you would be screwed for this question. Alright? That's the fact. Now, I use that here instead of logarithm base x of 3. And then I just end up with a fraction. And nobody likes fractions in equations. So I times everything by logarithm base 3 of x, and that gives me a quadratic. Alright? Logarithm base 3 of x all squared. Alright? It's not x squared, where you can just move the power down here. Alright? It's the whole function squared. Minus 2 is equal to, there's 1 times logarithm base 3 of x, logarithm base 3 of x. Okay? And then you just solve it as any other quadratic function. You put everything to one side equal to 0. Alright? You could make logarithm base 3 of x equal to y to make things easier for yourself. Alright? But you could skip that step and just factorize it as it is. Alright? And you end up with logarithm base 3 of x is equal to -1, logarithm base 3 of x is equal to 2. You change that from a logarithmic function into an exponential function. 3 to the power of -1 gives you x, 3 squared gives you x, and so x is a third and x is 9. Alright, that's logarithms for you. Alright, the only way you're going to get good at this is if you practice, practice, practice. Alright, I just showed you the basics and gave you a couple of examples. Alright, this has been the Awesome Tutor. Bye.